Why do randomness and determinism coexist? Have you ever wondered if there were an all-knowing observer in the universe who could replay or fast-forward the motion of every single atom at any time, would our seemingly random choices have already been determined at the very birth of the universe? In other words, is the current state of the universe the result of its past or the cause of its future? This brings us to the Laplace's demon, a creature that firmly believes in determinism. In its eyes, the future is destined to fade away, just as the past is clearly visible. The question is, when it accidentally opens Schrödinger's box and sees, for the first time, a cat in the superposition of being both alive and dead, what kind of illusion would it fall into? As early as 1814, when Napoleon questioned why determinism made no mention of God, Laplace bluntly replied, "I have no need of that hypothesis." For example, celestial mechanics can prove that the solar system was formed from the balance of gravitational and repulsive forces in a nebula, with no need for a prime mover at all. In his letter, he wrote, "Humans cannot precisely obtain all initial conditions, so we need to use probability to describe phenomena. Randomness is not an inherent property of nature, but rather the boundary of human cognition." In this regard, Einstein firmly supported Laplace's demon, which gave rise to the famous declaration that God does not play dice. In 1935, Schrödinger, in order to bring quantum randomness and macroscopic determinism into direct confrontation, devised a thought experiment. He placed a cat and a radioactive particle inside a box. If the particle decayed, the cat would die. Conversely, the cat would remain alive. According to quantum mechanics, the wave function of the radioactive particle remains in a superposition of decayed and undecayed states, and the cat also stays in a state of being both dead and alive. Only when the box is open does observation occur, causing the wave function to collapse into a definite state. In this way, microscopic randomness is amplified to the macroscopic level, which clearly challenges Laplace's demon. In response, Heisenberg pointed out that Schrödinger's cat does not actually involve true subjectivity. His original intention was to shift the description from the particle itself to our knowledge of the particle. In other words, the observer and the observed cannot really be distinguished. On the stage of the universe, we are both the audience and the actors. The remaining question is whether randomness and determinism, like wave-particle duality, also follow some kind of complementarity principle. And will this ancient battle between Schrödinger's cat and Laplace's demon reshape human thought once again in the future?